So we're seeing here we've got BGP state established now. If we'd done this when it was at this state, it would have said active there. So that means it's completed its handshakes and everything's done, and it's pushed over its topology table and all that good stuff. But again, we've got no routes here, so we're not sending out anything and we're not receiving anything. So let's just put some routes into this table, BGP 65002, and we'll just put one of these networks in right now. So remember, we configured a loopback interface here while we're waiting for the BGP topology to be built. Sorry, just a relationship to come up. So loopback in 0, IP address 150.1.1.1. That's just one of our loopback interfaces. Now to bring that into the BGP routing process, we use the network statement followed by the IP address and net mask of the network you want to bring in. Now, unlike an iGP, network doesn't mean activate BGP on this interface. So, for example, where you've got OSPF, if one of your Ethernet interfaces had IP address, say for example 1.1.1.1, 255.255.255.0, and you wanted to put OSPF on that network, you'd use the network 1.1.1.1.0.0.0.0 area 0 keyword statement to enable OSPF on that interface. Well, on BGP, the network statement doesn't mean that. It just means push this network into the routing process. So we've done that with that statement there. So now if we go to R2, we should be seeing some well, one route in the routing table from BGP. And we do. So B is BGP. There's the network we introduced with the network statement. You see we've got a distance of 20 there. That is the eBGP default distance for iOS, and you can see we've been receiving that for 14 seconds. So from 24.112, which is R4's Ethernet interface closest to us. So there you go. So we've got the EGP session built and the iBGP session built. We've got one loopback interface on R4 injecting its network into the routing process, and R2 picking up that route here in this routing table. And you can there's also show IP BGP, which shows you the BGP topology table, not the routing table. So this is like the rib, the candidate for BGP to be able to push its routing table into the actual BGP routing table into the actual operational routing table. And you can see we've learned this network 150.1.1.0/24. Yeah. So let's have a look at R1 here. Let's just get rid of some of this debug stuff. So let's see if we've got that network in our routing table, and we don't. So R4 has sent its network 150.1.1.0/24 into R2. R2's got it in its routing table. That's all nice, but R1 hasn't got that in its routing table. So what's the deal with that? Well, R2 will pass that route on to R1. So is it in R1's BGP rib? Yes, it is. So here's the network, and we've learned it from 24.1.1.2, which is R4's Ethernet interface. And so here we go. Here's one of the principal challenges here with BGP. What we've got is a network learned from our iBGP neighbor with the eBGP neighbor's IP address. Now, because R1 does not know how to get to the eBGP's IP address, it does not install that route into the routing table. So how do we get around this? Well, there are two ways off the bat that we can do here. One is tell R1 how to get to R4's Ethernet interface. So remember, we've got the routing table just says nothing, right? Because we don't know how to get to 24.1.1.0/24. So we can either maybe configure OSPF between R1 and R2 and allow R2's 24110 network into the OSPF process so that it advertises that to R1 and we learn it with OSPF. We could put a default route in, static route on R1 to point to R4's Ethernet interface, or we can use BGP to change the next hop IP address here to a next hop that the R1 will understand, which is basically its inside interface. So the network connection between R1 and R2 is 123.110. If we configure R2 to change the BGP next hop to an IP address 123.112, which is R2's inside interface, then this should all work. So we'll do that one first, and then I'll cover the we'll cover the routing table bit second. So in R2, we're going to configure mode again, configuration mode. Route BGP 001, that was our AS number. Now if you remember, we did the neighbor command again, so neighbor 123.111, that's R1's IP address, and we say next hop self. That's all we do. So now we're saying that when we're talking to neighbor 123.111, change anything that I give it from the next hop learned by me to my next hop, to my IP address, I beg your pardon. So it converts the next hop in the BGP information to me. So now where we have this show IP BGP showing the next hop as 24.112, we want that to say 123.112, which is R2's inside interface. So let's do that, show IP BGP. So now we've got 123.112. Now I know how to get to 123.112 because I'm locally connected to that network. Here we are, locally connected 123.110. Yeah, so I know how to get to that network. So now, if you look, we have the old greater than sign there, and that means I know how to get to that. I know how to get to that. So if we do a show IP route now, we should have the route installed in the routing table, which we do. And notice it's iBGP now, so the distance we've got is 200, whereas before the distance was 20. Whoops. There. Okay, so that's changing the next hop so that we can have iBGP neighbors see routes which have the wrong next hop, because it can't process that. Let's turn that off. Let's turn that off. There we go. So now we're going to go back to the bad old days where we can't use that route. We'll just have to wait for this to clear out. Or we can do a clear IP BGP. That rips it out. Yeah. So if you guys got any previous, if you're in your lab, this is probably one of the most common commands when you get into the end of the lab, because it just basically resets the BGP process and makes it all start again. So there we go. So we've got the down and an up. Basically tore down the neighborship between between router 1 and router 2. So now router 1 is going to learn all the information it needs again. So we've got no route, but have we got it in the BGP table? Yes, we do. So here we are. We're back again. So the next hop is 24.112. And remember, we don't know how to get to 24.112, so we can't get there. So let's put in a route to 24.110. The net mask and the gateway. So the gateway is going to be R2's, the interface closest to us on R2, which is 123.112. So now we know how to get to 24.110 with that mask. We should be able to get to 24.112. So this should come into the table without us changing the next hop now, right? So let's just have a quick look at that. Show IP BGP. What am I doing? iBGP. So we know how to get to the next hop, 24.112. I think. What's your? There we go. Right. So it wasn't. It's very early in the morning here, but so network. You see, it wasn't in the Now it is in there, so we know how to get to 24.1.1.2 now because of the static route we put in, and so now it's in the routing table. Let's just check that. See, it's in the routing table, and it is. So then you can see there's the full routing table. So you can see the static route we put in to get to the next hop, and we can see the route learned via that next hop there. Okay. So that's just two ways to do it. So the other way will be maybe we could enable OS. So let's do the OSPF one. Let's take the just a little bit of fun. Let's take out the static route. So we've taken out the static route. So now the router does not know how to get to the next hop for that network in the BGP table. We do not know how to get to that next hop anymore. So this will age out as a valid route. Maybe. So you see what I mean about BGP, yeah? So if you're in your lab and you're running out of time, the last thing you want to do is wait for BGP to update itself. I mean, you can change the timers, but if the lab doesn't tell you to do that, you don't do that. So okay, let's leave that for a minute. Right, we're going to configure OSPF between R2 and between R2 and R1 to inject the network that R2 knows between R2 and R4 into the OSPF process, just so R1 gets into its table. So we're going to do this really quick because it's just an example. So router OSPF 1, that's our process ID, remember. So that's locally specific to me. It's a process number, it's not an AS number. So we're going to do network. In fact, let's do this properly. So we'll do router ID 2.2.2.2 network 123.1.1.2. We'll give it a 32-bit mask, so it's just for that specific interface. We'll put that in area 0, and we'll do the same for network 24.1.1.2. Sorry, 1.0.0.0.0 area 0. So we configured OSPF, and we're injecting the networks connected to closest to R1 and the network closest to R4. Okay, and then on R1, let's just check that's aged out now, which it hasn't. Great. Let's get rid of that. It's doing nothing. Let's get rid of that. So let's put OSPF on here. What am I doing? Right. By the way, you don't have to do the router ID, but we'll use it later on in the example, so we might as well put it on now. Let's put the network statement in now. So hopefully the OSPF adjacency should come up.